Okay. So good afternoon, everybody. I want to pick up right where we left off last class. And if you remember last class, we were talking about this normal normal bell curve. And let me just see. I believe I posted the recording for it. Yeah. Excuse me. So if you go to course content and under the week 9 tab, there's this table here called the standard normal table. Has anybody had a chance to download it and have it ready for class?
Yes.
Got one yes. Anybody else in chat? Okay, good. Have this handy. We're going to use this a little bit later on in class. It's going to be our first statistical table. We're going to learn how to read. And it's actually like, if you look at it, that looks like there's a ton of numbers on it, but it's actually like super easy to read. And then also I have this PowerPoint here that I posted that I'm going to follow along. Okay. The only other thing is homework number 4 is now posted. So if you go under the homeworks tab here, here's homework number 4. This is due next Tuesday. And you'll actually be able to do this after class today, but I would hold off on doing it until it's a very short homework. I would hold off on doing it until Thursday. I know everyone probably hates to hear this, but today I'm going to show you how to do a lot of this stuff by hand. And then on Thursday, I'm going to show you a little bit easier way on the calculator. So, but the reason I show you how to do this by hand is because doing it by hand comes up later on in the course when we get to the final section, hypothesis testing. So you have to remember how to do it by hand. So it's not a total waste of time. Okay. That was just a quick rundown of some announcements, but does anybody have any questions about anything before we get started? Is someone talking? I can't hear them.
Nope.
Everybody good? All right. All right, so this is kind of a quick review from last class. So last class we were talking about the normal probability distribution, okay? And so when a random variable is normally distributed, okay? And for all the problems that we're going to do in this class, you'll be told this. Okay, so when a random variable is normally distributed, okay, we can model using what's called the normal density curve. And it's just this bell-shaped curve like this. Okay, and the important thing about it is it's centered at the mean mu. Okay, so the bell curve is centered at the mean. And then I gave you this formula for it. So this was the formula for the normal probability density function. Okay, and it turns out that this formula is like super complicated and we're not really going to use it that much. I said, okay, this formula is complicated. There has to be some tricks we could use. And so right after that, we went into the properties of the normal density curve. So again, it's symmetric about the mean. The mean is equal to the median, the mode. So there's a single peak going back, which you see here, single peak. The total area under the curve is 1. This is how we relate it to probability. Okay, and that's all we're going to be answering today in all our examples is a bunch of probability questions. Because it's symmetric, the total area under the curve is 1. That means the area to the right or left is equal to 1/2. So half the area is above the mean, half the area of the curve is below the mean. And then we talked about how it increases without bound, but the big thing is this empirical rule. And I think we did one example really, really briefly last class. Was it talking about iPhone talk time? Does that ring a bell?
Yeah, slightly.
Slightly. We just did one quick example of iPhone talk time. All right, and then I put up this graph. So hopefully this graph right here, you guys remember from last class. Okay, I know it was 5 days ago and lots happened over the weekend and stuff for everybody. But the big thing here to remember is, look, 68% of the area or 68% of observations fall within 1 standard deviation of the mean. On either side, 95 within 2 standard deviations and 99.7 within 3. And you can see these little like shaded areas here. This represents the proportion that falls between the mean and 1 standard deviation above and the mean and 1 standard deviation below. Okay. Is everybody okay if I go to the next slide? And what we want to do is just work some examples. Storm tells me we're good. Everybody else okay? Okay. I'll take silence as a yes. So here's the problem that we're going to work today. It goes like this. Suppose that the commute times of college students at WCC is normally distributed. Okay, so right there, notice how I'm telling you that commute times is normally distributed. Normally distributed with a mean of 30 minutes. So right there, I'm telling you that mu is 30. And standard deviation, I'm giving you that too, of 7 minutes. Okay. And it says, suppose a student is selected at random and their commute time is recorded. Okay. So now here's the thing. When I select a student at random, do I know exactly how long their commute time is going to be to get to campus?
No.
No, it's just like, it's going to be, thank you. It's going to be a random number. It's going to be a random outcome. Okay. So it's going to be an unknown variable here. So I'm going to define this variable x. Okay, so I'm going to be letting the random variable x be the commute time of the randomly selected student. And this is all we're saying. We're saying, okay, look, the random variable x follows. So when you see the squiggly line, it means follows or approximately normally distributed. With the mean of 30 minutes. So on average, we're saying it takes students 30 minutes to get to campus and a standard deviation of 7 minutes. Okay, so basically what I'm gonna do now is I'm gonna just redo basically the iPhone question that I was asking last time. I'm gonna ask, random variable, draw the probability density function, and then answer some probabilities. Everybody okay if I go on to the next slide?
Just 1 second, please.
Okay, all good. Okay. So here's the thing. If you printed out the slides, I didn't have this in this chart in the slides, but I moved it over here just to have it handy. Okay. So X is the commute time of a randomly selected student. Okay. Is it a discrete or is it a continuous random variable? What do you guys think?
Discrete.
So discretes are counts, or is commute time, or is time a measurement?
Times a measurement. So
Okay.
continuous.
Yes.
Yeah.
Okay. So the commute time is a continuous random variable. Okay, so next it says sketch the density curve for the random variable x. So if we go back, this right here is the density curve. Okay, it's this bell-shaped curve centered at the mean. So all you're going to do to sketch the density curve for something that's normally distributed is you're going to sketch this normal distribution like so. Okay, that's not the best, but you get the idea. Okay, so I got this bell curve shape, this normal distribution. And I'm going to draw a dotted line down from the mean. Okay, and does anybody remember what the mean is here?
The mean was 30.
Yep, so that's going to be the center. Okay, just give me 1 second. Hold on, I just got to go on mute for 1 second. Sorry, everybody, just give me a second. Okay, sorry about that. So the center of the curve is 30 here. And do you notice over here, all right, where basically where this curve was, I'm replacing this mu with 30. Okay, so then next what you're going to notice is it takes the mean and it's adding a standard deviation, then it's adding 2 standard deviations and adding 3 standard deviations. So the standard deviation was 7. So I would take 30 and I would add 7, I would get 33. I would add another 7, I would get 44. And then I would finally add another 7, and I think I would get 51. Does everybody see what I did there? I just took the mean and I added the standard deviation 3 times. Does that make sense, what I did there? Okay, I got 1 yes. So now I'm going to do the same thing on the other side, okay? So I'm going to subtract some standard deviations. So I'm going to take 30 minus 7 gets me 21. Or 23. 21. I'm going to subtract another 7, okay? And when I subtract another 7, I get 16. And then when I subtract another 7, yeah, bad math today. I'm going to subtract another 7, and I'm going to get 9. Okay. All right. So now here's the question. What is the probability the commute time is between 16 minutes and 44 minutes? All right, so I'm just asking that commute time on that random student is somewhere between 16 and 44 minutes. Okay, so the way you're going to solve these problems, okay, the first thing you're going to do, you're always going to follow these steps. You're going to do 1, you're going to write the probability statement. All right, step 2. All right, you're going to sketch the density curve. All right, so when I say, let me go back. When I say write the probability statement, that's this right here, okay? The probability you're looking for. Next, you're going to sketch the density curve. Well, the good news is we've already done that up here. Now, the third thing you're going to do is you're going to shade in the area of interest. Okay. So look, do you guys see on the curve here the numbers 16 and 44? Do you guys see them along the curve somewhere?
16 and 44.
Yeah. Do you see the number 16 and 44 along the bottom?
Yes.
Yeah. So just go to 16, just go to 44. And you're going to shade in the area between those. Okay. Okay. So now you need to find this red shaded area. So for here, now use the chart to find the area. Okay, does anybody think they know what the answer is? Why is it you? That's the exact right answer, Jamie. Why is it 95?
I had the chart with the curve, and then I added the 2 standard deviations below 30 and then 2 above, and then added those 4 numbers together.
Yep. Yes, that's perfect right there. So look, do you notice how to go from, this is what Jamie did. Do you notice how to go from 30 to 44 is 2 standard deviations? So you went from here to here. So that includes this area and this area. And from 30 down to 16, that's from 2 standard deviations here. So that includes this number and this number. So since it's a probability, you're just going to take it and you're going to change them to decimals. And you're just going to add them up. And you get 0.95. What do you guys think? I mean, I'm going to do a couple more, but is it kind of ringing a bell from last time? Not too bad, not the worst.
Not the worst.
Not the worst. Right, not bad. Yeah. All right, well, let me do some more examples. I got 2 more examples picked out, and then you'll no, not really. We will do problems where something involved being more than 3 standard deviations does come up, but not for these simple problems, Bertha. No.
We would also have to memorize like 34, 13.5, and 2.35.
So you'll never have to memorize this stuff, right? So like all the exams and homeworks are open notes, so you don't have to stress about worrying or remembering it, you know.
Thank you.
Mm-hmm. All right, let's do 2 more questions as a follow-up to this. Okay. All right, so now what is the probability that the commute time of the student is less than 23 minutes? Okay. So it's the probability that the commute time X is less than 23. Okay. All right, so the first thing, going back, we write the probability statement. We got it. All right. So again, let's sketch the density curve. It's going to help us. Okay. So you're centered at 30. And then let's tick off those standard deviations again. 37, 44, 51. And then again, so 23, 16, and 9. All right, so now here's the thing. I want to be, as you go back next, shade in the area of interest. So you're going to go to 23. And you're going to shade in the area. So I'm going to shade in everything. Okay, let me ask you this question. If I want to be less than 23, do you think I would stop at 9 or do you think I would keep going? So my numbers only go to 9, but
Yeah, keep going.
yeah, you're going to keep going. You want to be everything less than. You could be more than 3 standard deviations away. It's not likely, but you could be. All right, so we want to find all that area there under the curve less than 23. Okay. Does anybody? I don't. I'm at a loss. I'm really at a loss. Does anybody have an idea on how to do that? Okay. Well, let me ask you this. To go from 30 to 23, right? So that's from the mean to 1 standard deviation. What is this unshaded area where my pen is going over here? What is that equal to? Yep. So just got to change it to a decimal. It's 0.34. Okay, so does anybody remember how much area falls? So remember, now let me stop for a second, getting ahead of myself. I don't want that 34%. Okay, that's unshaded area. I don't want it. So does anybody remember how much area has to fall below the mean? Remember, the total area under the curve is 1. So how much area is to the left of the mean? If you look back in your properties. Yes. Yep. Thanks. 0.5. Well, if 0.5 is all the area to the left of the mean, but I don't want this 0.34, what do you think I should do? If I don't want it, I should do what with it? Yes, Ken's got it. Since half the area is below, yep, and Jamie's got it there, but you don't care about this 0.34, you're just going to take it away. And that's your answer right there. So let me ask you, it's kind of a similar question, but let me ask you this one. Okay, what is the probability that the commute time is greater than 44 minutes? Okay. Yes, everything would be 0.15. Yes, Jamie, you could also do it that way. All right, so what is the probability the commute time is greater than 44 minutes? Okay, so again, we wrote the probability statement. Let's sketch the density curve. You're centered at 30. So 37, 44, 51, 23, 16, and 9. And you want to go to 44. And you want to be greater than 44. Okay. Does anybody have a suggestion on how to tackle this one now?
Would that be shaded in the 3rd standard deviation? Like if we're looking at the graph,
Say that again.
is that shaded in the 3rd or is that still part of the 2nd?
What do you mean? I guess I don't understand. I'm sorry.
So where it's shaded, is it shaded part of like the 2nd standard deviation of the mean, or is it part of like the 3rd if we had to look at it?
It's the 2nd. So it goes from here's 1, 2 standard deviations from the mean. Right? To get to 44 would be 2 standard deviations from the mean.
Okay.
So look, how much area falls above the mean? It's 0.5. That's because half is below, half has to be above. Well, look, notice how this area here and this area isn't shaded. Well, that's this number and this number because it's 1, 2 standard deviations.
And then we just, I
Yeah,
was gonna say add, but
you could add and then subtract it. You absolutely could. So when even if you were to add these two numbers, you'd get 0.50 minus 0.475. And the answer would be 0.025, I believe. Okay, so it's hard for me to see everybody's faces, but yeah, go on ahead, Jamie.
Do we have to write it as like 0.025, or can we do like, is that the only right way of writing it?
Yeah, so probabilities you never want to write as a percentage.
Okay.
You always want to change it to a decimal.
Okay, thank you.
the only thing that's kind of confusing me is where we get the 0.5 from.
Go on ahead.
I thought we were looking at the graph to get like the table to get that, but I feel like I'm wrong on that.
Yeah, so the one thing that's tough to remember is that the total area under the curve is 1. Okay.
Mhm.
And so since it's symmetric, what that means is half the area or 50% are below the mean, and half the area or 50% of the area is above the mean. So it's not like explicitly put on the chart.
Okay. Thank you.
No problem. So I don't actually want to spend a lot of time on doing problems this way because let me ask you this. Is the empirical rule like a little confusing using that chart there? Like it's just not like the most.
It is not. It's easy.
It is easy. Okay, that's good. Sometimes people are like, it's not really user friendly. So it turns out we're not actually going to do problems this way. Okay, so. Okay, there's going to be a different way. And the reason we won't do problems this way is like, what if I asked you this question? Okay, what if I said, what is the probability that the commute time is less than 33 minutes? Okay, does 33 minutes show up anywhere on there? Like, is there 30? Yeah. So there's like no way to do it if I asked you that problem because there's no 33 on the on the chart here on the number line. Okay. So, but there has to be a way to solve that type of problem. And that's what I want to show you. That method is how we're actually going to do problems going forward. Okay. So I'm actually going to skip example number 2 just to save a little time because we actually won't do problems this way. And I'm sorry, is everybody okay if I go on to the next topics?
How comes Melissa is quiet today? Is she in class?
Oh, let's see. And Melissa, you're right. Oh, she's there. Look, she's here.
Oh, okay. Thank you. Melissa, you have to participate.
That's okay.
Okay, thank you.
That was a funny catch. I was like, the chat does seem a little silent today. Okay. All right. Everybody okay if I go on? That was funny. All right. So what we're going to spend time now talking about is what's called the standard normal distribution, okay? And this idea or concept of a standard normal distribution is going to bring back the concept of z-scores. Yes, I did skip a few slides. I just didn't want to do the next example, Bertha. I just wanted to move on. Okay, so z-scores. Do you guys remember let me ask this. Does z-scores kind of ring a bell to people?
Yeah.
Yeah, do you guys remember? I talked about the first example I did with it was teacher salaries. Does that, like compare these two teachers. It was two teachers named Nicole and Jeff. Okay. Well, so here's the problem, and this is going to talk about why we need z-scores, okay? So suppose the talk time on the iPhone 10 is normally distributed with a mean of 20 hours. So you could talk for 20 hours and a standard deviation of 5 hours. So it's a mu of 20 hours and standard deviation of 5 hours. All right, suppose an iPhone 10 is selected at random and its talk time is recorded. Okay, so again, if we just select an iPhone 10 at random, we're not going to know how long its talk time is going to last, okay? So we're going to let the random variable x be the talk time on that randomly selected iPhone 10. So the question is what is the probability that the talk time on a randomly selected iPhone 10 is less than 18 hours? Okay. So look, if you were to sketch the density curve for this, you would see kind of what I was hinting at, okay? Oh, that's a terrible curve. I'm sorry. Not my best work today. Here's 20, and then you would add a couple standard deviations, 25, 30, 35. You would subtract. You'd get 15. You'd get 10. You'd get 5. And look, 18 does not fall on a nice standard deviation. It's kind of like right here. So you'd still shade the area to the left that you're trying to find. But you cannot use the empirical rule anymore. Okay, you cannot use the empirical rule anymore. So we need a different way to solve this, okay? And what I want to do is I want to show you how to solve this. And this is going to involve learning how to read your first statistical table, okay? All right, is everybody okay if I go to the next slide? Okay. So we're going to introduce what's called the standard normal curve. So this goes back about the standard normal distribution, the standard normal curve or standard normal distribution. And all this is it's just a very specific normal distribution. So when you in mathematics, okay, what do you think the two easiest numbers to work with are in math? Like what are easy numbers in math?
Positive numbers.
Well, let me ask you this. Is the number 1, is that an easy number to work with?
Yes.
How about 0? Is that an easy number?
No.
Okay, so that's what I mean by easy numbers. So sometimes, you know what, Sarah, that's a good answer. Sometimes it is, yeah. So all the standard normal distribution is a normal distribution or normally distributed variable having mean of 0, and standard deviation of 1 is said to have the standard normal distribution. So it's just mean, mu is equal to 0, and standard deviation sigma is equal to 1, okay? And like, I'm just going to go back real quick and then I'll come right back to this. Like, in this example, we worked here, okay? It was just mean of 30 and standard deviation of 7, okay? In the next example I was going to do, but I skipped it, the mean would have been 120 minutes and the standard deviation would have been 30 minutes, okay? So all this is, you're considered a standard normal distribution is if you just have mean of 0 and standard deviation of 1, okay? So this is what the standard normal distribution looks like. It's centered at 0, and then it has standard deviations of 1. So if you had 1, 2, 3, -1, -2, -3. And then it has literally the same properties of the normal curve. Okay, it literally has the same exact properties as the standard normal curve, okay? What's really interesting, okay, and I'm going to go to the next slide if everyone's okay. What's really interesting is you can take any normal curve or any normally distributed variable and turn it into a standard normal variable. So you can take any normally distributed random variable x, okay, and I'm going to put in parentheses, turn it into a standard normal variable. So the standardized version of a normal variable x, we denote with the letter z, okay? And this is where the z scores come from, okay? All you're going to do is you're going to take the value of the random variable, okay? So I'll even rewrite it so you can see. You take the variable, you subtract mu, which is the mean, and you divide by sigma, which is the standard deviation. Okay. And this new variable has what's called a standard normal distribution. Okay. So all you're doing is really, when I say turn it into, what you're really doing is you're transforming it. Okay. Do you guys ever feel, and I know I say this a lot, but do you ever feel like when I present stuff and I do these definitions, it doesn't make sense until I do the example? I know I say this all the time, but like you ever kind of feel, you know, is that kind of feel what's going on with this one? Yeah. Thank you for being honest, Jamie. Yep. Trust me, all this stuff. Yeah. Just let me get through the definitions as I have been. And then once I get to the examples will, I promise it'll make sense. Okay. Everybody okay if I go to the next slide?
One second.
Sure. No problem.
I'm okay.
Okay. Okay. So this is all that happens. If you look here, I have 3 different normal curves. Okay, I have this green one, and this green curve has a mean of -2 and standard deviation of 1. I have this red one here, has a mean of 3 and standard deviation of 1/2. And I have like this beige one here that has a mean of 9 and standard deviation of 2. Okay. Now, all normal curves have the same properties. They just kind of look slightly different. Okay. But the look doesn't really ultimately matter because what matters is the properties. And if you were to take these curves, okay, and you run them through that z-score formula, the x minus the mean divided by the standard deviation, it transforms all these curves into a standard normal curve. Okay. Now, why do we care? Okay. And I'm sorry to go ahead, but like what, like, okay, it's great. That's a cool trick. You can transform, but like, why do we care, Matt? Like, what's the big deal? And let me show you. Okay. So what we're going to have here is I'm going to put that iPhone talk time distribution. Does anybody remember what the mean talk time was for the iPhone?
For the first one, it was 30.
That
Or-
was commute times. I'm sorry. So
20.
20, yeah, 20 hours. Yep. And does anybody remember what the standard deviation was? Yep. Okay, so if we were to sketch this curve, we'd go 20, 25, 30. I'm just going to go 2 standard deviations, 15, 10. Does anybody know or remember what the area is under the curve between 20 and 25? So between the mean and 1 standard deviation above the mean? Like, let me go back. So what is the area under the curve between 20 and 25? So from the mean to 1 standard deviation.
That's 34.
Yes. Yep. Perfect. 0.34. And so let me draw the standard normal curve now. Okay. So the standard normal curve has mean of 0 and standard deviation of 1. So I could add 1, I could add 2, I could get -1, -2. Does anybody think they know what the area under the standard normal curve between 0 and 1 is then? Well, let me ask you this. Is it literally the same area between the mean and 1 standard deviation? What do you guys think?
I would say yes.
It totally is. Yeah, look. The mean to 1 standard deviation. The mean to 1 standard deviation. So they're equal areas. Okay. And it's what's really cool is look, you can take, using the z-score formula, you can take any normally distributed variable and turn it into a standard normal variable. Okay. So like, why do we care? Like, what's the big deal? Like, if you go back to the classroom, okay, and under week 9, I said, have this standard normal table here. Okay. Everybody see this table here, at least on my screen?
Yes.
So what's amazing is that I have this table now that can give me areas for the standard normal variable. But what I can do is I can take any normally distributed variable, turn it into a standard normal variable, look that up on the chart, And that's going to be the same area as over here. And that's what I want to show you how to do during this second part of class is I want to show you how to read this table and then just work a bunch of examples. Okay. So there was a lot in 46 minutes. So I actually think this is a good spot to take our break, if that's okay. And then when we come back from our break, I'll show you how to read this standard normal table. So what I highly recommend is during our break, if you don't have this printed out, to like go print it out or load it up on your computer, okay? Because learning how to read it and having it like, you know, it's better to have it handy than to just watch me read it. Okay, so let's take our break. And let's come back. Let's just say 2 p.m. We'll have a little bit of an extended break today, if that's okay with everybody. Sound good?
Yes.
All right. All right. I'll see you guys in 13 minutes. All right, everybody can hear me okay?
Sure can.
All right, let's finish up for today. Okay, so hopefully what you're gonna need is you're gonna need to have this handy, and then I probably should have done this. And then you're actually just gonna wanna grab your calculator. Doesn't matter which one for today. Okay. So if you look back at this table here, okay, do you guys see right at the top where it says standard normal probabilities? Okay. And then what this does is the table entry for Z is the area under the standard normal curve to the left of a specific Z score. So the table here, okay, I can't stress this enough. Oh, come on, graph. Calculator. I can't stress this enough. The calculator, just do this one. The calculator, oh my gosh, sorry. The table gives the total area to the left of any Z-score, okay? So when you find a Z-score, what the table will do is it will tell you all the area under the curve to the left of that specific Z-score. And if you scroll down, do you see how the table has two sides? Okay, you have this one side here with Z and then just a little bit of area shaded here, okay? Can I just get one verification that people are are with me on this, that I see this table? Good, good, thanks. And what you'll notice here is this just looks like a little area here. This side is for negative Z-scores. And if you scroll down here, do you see how this one has a lot more area shaded? Do you guys see that? Okay, this is for positive Z-scores, okay? And I'm not even going to talk about how you read the table right now. I'm just going to like jump right into an example of reading the table and show and use those examples to show you how you read the table. Okay. So just this is really important. The table only gives the area to the left of a specific Z-score. Okay. So the table gives the area to the left of a Z-score. Okay. But there's three ways I want to show you how to read the table, okay? The first one will be real easy if I just say what's the area to the left of a z-score. The other way I'm going to show you how to read it is if I ask you for the area to the right of a z-score, okay? To the right. Right? But that's weird, right? Because you're like, well, Matt, you just said the table only gives the area to the left, but I'm going to show you how you find the area to the right. And then I'm going to show you how to find the area between two z-scores on this standard normal table. And then after we have learned how to read the table, then what I'm going to do is I'm going to show you how to answer that iPhone question, that probability question. Okay. So it'll be real quick actually to read the table, and then we'll jump right into examples. All right, is everybody okay if I go to the next slide? Okay. All right, so the first one is the area to the left. Okay, so the first thing I want to do is I want to find the area to the left of a z-score of negative 1.25. Okay. So here's the thing. All right, I find that the drawing of the normal distribution helps in finding the area. Okay, so whenever I reference a z-score value, okay, you're always going to draw the standard normal. So I want to find the area to the left of a z-score of negative 1.25. Okay, so I'm going to draw this normal curve. Does anybody remember what I said the mean of a standard normal distribution was? I said it was one of the easier. Go on ahead. I'm sorry.
Is 0.
0. Yeah. And so negative, when I do these problems going forward, I'm no longer going to count off standard deviations anymore. You're not going to need to do that. So instead, I'm going to say, okay, I want this value of negative 1.25. That's over here. And I want to find the area to the left. So I'm going to shade the area to the left. Okay, so now look at this. While it's not perfect, does this area here, does this curve shaded kind of look like this one right here? Do they look kind of roughly the same? Do my pictures look the same, I mean? Yes. Okay, they do. They do. Okay, so what that means is I can now use this table to find that area. Okay, so look at your table here. There's a thing at the top called a row header, okay? And then there's this column down the side here. That's your column header, okay? So to look this up, the way you're going to do this on the table is you're going to look at the first two digits of your z-score, okay, which is negative 1.2. And then you're going to go to your table. Can you guys find on your table, see right here, negative 1.2?
Yes.
You guys see that? Okay. And then at the top, what you're going to do is you're going to go to the last digit of your z-score, which is a 5, so negative 1.25. And then you're going to look where they intersect. So look where the negative 1.2 and the 0.05 intersect. And can anybody tell me what number they see right there? Yeah, and that's your answer right there. 0.1056. And that's it. Was that pretty easy to read?
Now it is. Now it is.
Now it is. Okay. So here's the thing. This z-score table only goes to 2 decimal places. Okay. So whenever we do these problems, you'll see eventually I'll start rounding numbers off. So they always go to 2 decimal places, but that's it. That's all you have to do to read the table. All right. Sometimes these problems will be written as probability statements. Okay. So now what I want to do is I want to find the probability that a z-score is less than 0.85. So you're going to draw a standard normal curve. Centered at 0. And notice this is positive, so 0.85. That's over here. Okay, that's on the positive side. So I want to find the probability that a z-score is less than that. So that's the area under the curve less than that. So that's to the left. Okay. A little bit terrible drawing there, but you get the idea. Well, now look, scroll now to the positive side, okay? Notice how this curve now more better resembles this one, okay, with much more area. So look, all you're going to do is go to the first 2 digits, 0.8, which is right here. And then also this one goes to the 5. So 0.8 over to the 5. And can anybody tell me what number they get?
.8023.
And that's it. And that's that answer. That's the answer to that probability right there. .8023. And that's it. What do you guys think? Not too bad? Just reading the table? Is that what you're asking?
I have a question real quick.
Hold on, let me just get the question that was posted in the chat first. So you go to the first 2 digits first. So 0.8 are the first 2 digits. And then the last digit is a 5. So you look up at the top here and there's the 0.05 because the last digit's a 5. And then you just look where they intersect, right? So 0.8, whoosh, 0.05, whoop, 0.8023. And that's the answer. And I'm sorry for cutting you off. What was your question?
So for the first one, how you said find the area to the left of the z-score, you'll give us the number and we'll have to use the chart to find it?
Yes.
Okay.
So actually, so what's going to, you're going to end up calculating the z-score, but I'm going to give you enough information to do it. You'll see. So all this is right now is just learning how to read the table. And then you'll see in a couple minutes, I'm going to literally show you how to answer that iPhone question.
Awesome.
Okay.
Professor, how do we know which side of the table to refer to by the shade?
So it depends, right? So like this one here is going to, do you notice how the first 2 digits, it's a negative number?
Yes.
So this side is for when you have a z-score that's negative, and this is when you have a z-score that's positive.
Oh, okay. All
That's
right.
how you'll know.
Thank you.
All right, let's do, so this is area to the left. The area to the left is the easiest one. You just read right off the table. Okay, so the next thing I want to do, look, so we reading areas to the left, piece of cake. Whoop. Okay, this one right here, I want to talk about how you find areas to the right. Okay. And notice, just to go back, the way you're going to do it is 1 minus the area to the left, and I'll explain that. Okay. So let's find an area to the, area to the right. A little bit of a typo here. area to the right of a z-score of 1.30. Okay, so the way you're going to do this, I always find that the drawing helps. Okay. So I'm going to sketch this normal curve. It's centered at 0. And I'm going to go to a z-score of 1.30. So that's to the right because it's a positive number. And I want to find the area to the right. I'm going to shade to the right. Just like that. Okay. So here's all you're going to do. You're going to go first up, you're going to look up a z-score of 1.30. Okay, so you're going to grab your table. You're going to go to the positive side here. Okay. You're going to scroll down to 1.3, and then the last digit is a 0. And do you guys see the number 0.9032?
Yes.
Okay. So that's the area to the left. But you know what? I don't want that area. I want everything else. I just don't want that area. Okay. So you have to realize that the total area under the curve is 1. So this area here has to be 1 minus the area to the left, which is what the table gave us. So it's 1 minus 0.9032. If you do that subtraction, you'll end up getting 0.968, I believe. And that's it. That's all you have to do to find area to the right. You just look up the area to the left and you subtract it. So all it is one extra step. Literally, that's it. All right, let me do this one here. Find the probability that a z-score is greater than 0.75. So you're going to draw the curve. .75 is over here. And I want to be greater than. So again, I'm going to shade to the right. So whenever you have an area to the right, it's always 1 minus the area to the left. So I got to go look up 0.75. So here's 0.7. And then the last digit is 5. Do you guys see 0.7734? So it's just 1 minus that. Which I believe gets you 0.2266. So look, even though the table only gives area to the left, you can use it to find area to the right. And that's it. Okay.
So area. So when we do area to the left, we're just finding the last, like that last digit number.
Okay.
Basically.
So area to the left, you just read off the table.
Okay.
And then area to the right is you do the area that you're looking for is equal to 1 minus the area to the left.
Okay. Makes sense. Got it.
That's it. And what you'll notice here is these drawings will help you. Okay. Because like when I sketch this drawing, I'll be like, oh, it's an area to the right. Oh, it's an area to the right. Okay. So now what we need to do is find the area between two z-scores. And that's really easy too. One second. Okay.
Professor, could you go back to the last slide?
Yeah.
I'm good, thank
Bless
you.
you.
Well, thank you. Yep, a little bit of a cough there. Okay. I just want to do one example of this area between, and then I'm going to actually move on to like the iPhone example question so you can see how to do an application problem. All right, so look, to find the area between two z-scores, the way you do that, okay, is you find the area to the left of the higher number and you subtract away the area to the left of the lower number. So let me show you that in practice. So I want to find the area between z is equal to 0.25. I have a lot of 5s in here for some reason. And z is equal to 1.25. So look, I find that the drawing helps. So you're going to draw a normal curve. It's centered at 0. 0.25 is over here. 1.25 is over here. And you want to find the area between them. Okay, so all you have to do for an area between, this red shaded area is equal to area to left of higher z-score or higher number minus the area to left of lower number. So the first thing you're going to do is you're going to go to your table. You're going to look up 1.25. I'm going to go to my table. I'm going to go to 1.25, which is 0.8944, 0.8944. And then I'm going to look up the lower number, which is 0.25. Here's 0.25, which is 0.5987. And I'm just going to subtract them. So grab your calculator here. So 0.8944 minus 0.5987. And you get 0.2957. 0.2957. And that's it. That's your answer. So this one here, this second one here just involves like just a little bit of an extra step, and that's it. Literally, that's it. All right, let me ask you this. Is reading the table not too bad? Now that you've seen me do it a couple times? What do you guys think? Okay. So all I want to do now with the time we have left is I just want to get through one quick example here and show you how to do one application problem. And so that you can see how this all comes together, okay? All right, so is everybody okay if I go to the next slide? Everybody with me? Hello? No? Okay. All right, I'm going to go to the next slide and just do one problem. That's okay. All right, so here was the problem. Suppose talk time on the iPhone 10 is normally distributed, okay, with a mean of 10 hours or 20 hours and a standard deviation of 5 hours. Suppose an iPhone 10 is selected at random and its talk time is recorded. Okay, so let's let X be the talk time on that randomly selected iPhone 10. Okay, so the problem was, what is the probability that the talk time on a randomly selected iPhone 10 is less than 18 hours? Okay. So here's how you're always going to do these problems. It's always these 4 steps, okay? First thing you're going to do is you're going to identify the variable and write the probability statement, okay? This first identify the variable is always going to be something like let x equal, and the probability statement is always going to be something like the probability that x is less than some number or greater than some number or between some number. Then what you're going to do is you're going to draw the normal density curve and shade in the area corresponding to the probability statement in step 1. Okay, so this part here is just draw the normal curve. Shade in area you're looking for. And we're going to get some practice with that. The next thing you're going to need to do is you're going to need to compute z-scores. Okay, and let me actually just move this down here. So a z-score is equal to x minus the mean divided by the standard deviation. So it's the variable value. That's what x represents, minus the mean divided by the standard deviation. And then once you have z-scores, you're just going to use the standard normal table to find corresponding areas. And that's it. Okay. And then that area here, this area is going to be equal to the probability. Okay. All right. Everybody okay if I go to the next slide?
1 second.
Mm-hmm.
Finishing up. All good.
Okay. Okay, so let's do it. Suppose talk time on the iPhone 10 is normally distributed with a mean of 20 hours and standard deviation of 5 hours. Okay, suppose an iPhone 10 is selected at random and its talk time is recorded. Okay. What is the probability that the talk time on a randomly selected iPhone 10 is less than 18 hours? Okay. Step 1. So going back, you're going to identify the variable. So we already have that up there, but I'll rewrite it. So we're going to let x be equal to the talk time on a randomly selected iPhone 10. And it says write the probability statement. Okay. And I want to find the probability that that talk time is less than 18 hours. Okay, step 2. Draw the curve. So what you're going to do is you're going to draw a normal curve. Okay. What was the mean talk time of the iPhone 10? What did I say the mean was?
Mean was 20.
Mm-hmm. And I want to be less than 18. So what you're going to do is you're going to draw the curve and then shade in the area. So I want to be less than 18. So 18 is to the left of it, and then I want to be less than. So I'm going to shade in some area. Well, look, this is awesome. Oops, sorry. Didn't mean to go so fast. I meant to go over here. Look at this right here. Does this curve kind of look like what I just drew right there? So you can kind of see how we're going to use this table now. But to be able to use this table, what I need to do is I need to convert it to z-scores. Okay. So step 3, convert to z-scores. Now, the only thing you have to convert to a z-score is 18, okay? The z-score of the number 20 is going to always be 0, okay? So we need to do 18. So it's x minus the mean divided by the standard deviation. Well, that's 18 minus 20. And what was the standard deviation for talk time?
5.
So this ends up just being minus 2 divided by 5, which is minus 0.40. So always go out 2 decimal places. Okay. If you need a calculator to do that, that's totally okay too. So now once you have the z-score, step 4, use table to solve. You can actually take this probability statement and it now literally becomes, what's the probability a z-score is less than negative 40, negative 0.4, excuse me. Well, look, I'm looking for an area to the left. This is how this all goes through. Area to the left, and I have a z-score. I literally just read it off the table. So the first 2 digits are negative 0.4, which is right here, negative 0.4. And then the last digit is a 0, which gets me 0.3446. Does everybody see that? Negative 0.4 and then 0.3446. Can I get one thumbs up that you got the same number? And that's it. That's the problem. 0.3446. What do you think? Not bad. Not bad. Yeah, I gotcha. Not bad. Yeah, it's not too bad. All it really involves is, to be honest with you, I find once you sketch the curve and understand what you're looking for, like the problem isn't too bad. Okay. So this is an area to the left. I got 2 more problems for you that I'd like to get through. So let me know if I can go smiley face with a tear. Then we're going to do some more examples. And then also, don't worry, we're going to come back on Thursday and we're going to start with another example of this too. All right. Everybody okay if I go to the next slide real quick? All right. I just want to get through these 2 problems and then we'll call it quits for today, okay? Okay, so what is the probability that the talk time on a randomly selected iPhone 10 is more than 24 hours? So here it's now the probability that X is greater than 24. All right, well, we've written the probability statement. Now let's sketch the curve. It's centered around 20. I want to go to 24. And I want to be greater than 24. So I'm going to shade to the right because I want to be greater than. Okay. After I do that, So I've written the probability statement. I've drawn the curve. Does anybody remember what I have to do next?
The area?
Well, before I go to the table and look it up, do I need to compute something?
Convert the z-scores.
I need a z-score. Okay. So in this case, I only need to compute one z-score. So the z-score is equal to x minus the mean divided by the standard deviation. So in this case, my x value is 24 minus 20, because that was the mean, and the standard deviation is 5. So that ends up being 4 divided by 5, which is 0.80. Okay, so this is now, what is the probability of z-score is greater than 0.80? Okay, so this is an area to the right, because I had my area shaded under the curve is to the right. Does anybody remember how to solve this? What do I got to do?
Would it be 1 minus 0.80?
So you're close. It is 1 minus something. But what you have to do is you have to look up the area first. Okay. So you got to go find 0.80 on your table. Here's 0.8. And then the last digit is 0, which is 0.7881. So it's 1 minus 0.7881. 1 minus 0.7881. So that ends up being 0.2119, I believe. So you always have to go to the table. Okay, that's important. You always have to head to the table. Ring a bell? Okay, how about one last one for today? You guys ready to do one last one and then we'll call it quits a little early if that's okay? Okay, sure. Okay. So what is the probability that the talk time on a randomly selected iPhone 10 is between 17 and 21? Okay, probability that you're between 17 and 21. So again, you're going to sketch your curve. "17 is down here, 21 is over here. And I want to find the area between these two. Okay, so I've shaded in the area. Okay. For this problem here, how many z-scores do I need to compute? Do you think? Yeah, 2. Yes, I need to do a z-score for 21 and a z-score for 17. Okay, you need to do 2 z-scores here. So let's do the z-score for 21 first. So it's 21 minus 20 divided by 5, which gets me 1 out of 5, which is 0.20. Then I need to do the z-score for 17. Which is 17 minus 20 divided by 5, which is minus 3 divided by 5, which is minus 0.60. So this literally just becomes now, what's the probability of z-score is between these two numbers? All right, does anybody remember this procedure, just out of curiosity? For two z-scores, I know I only did one example. What do I have to do?
Do 1 minus.
No, 1 minus is for area to the right.
Yeah.
You have to subtract something, but what do I have to subtract? What do I have to look up first? You have to look up their areas first, and then you subtract. So you always have to look up the areas, okay? So I'm going to go look up the area for this z-score of 0.20. So here's 0.2. Last digit is a 0. So it's 0.5793. 0.5793. And then you gotta go look up this other one, negative 0.60. So I've got to go to the negative side, negative 0.6, and then 0. So 0.2743, 0.2743. So let's just grab our trusty calculator now. So 0.5793 minus 0.2743. And you get 0.3050, basically. And that's the answer. Well, good news, everyone. You just learned how to read your first statistical table today. Exciting or what?
Super exciting.
Thank you for chiming in, Melissa. I appreciate that. Melissa was quiet today, and she's the best day of your life. Okay, all right. All right, everybody. I'm going to end class a little early today, 10 minutes. On Thursday, what we'll do is we'll do another example of this by hand, just so you can get used to reading the table. And then please bring your graphing calculator with you to class on Thursday. Okay, because if this was a little confusing, I promise I'm actually going to make everybody's life a little bit easier on Thursday and show you how to use your graphing calculator for this. All right, everybody, I'm going to stop the recording.